Right now, as you watch this video, something impossible is happening 200 million kilometers from Earth. An object from another star system is tearing itself apart, and Harvard's top astrophysicist just released data that changes everything we thought we knew. This isn't clickbait. This is real science happening in real time, and you're about to become part of the most significant astronomical discovery of the decade. July 1st, 2025. The Atlas telescope system in Chile detects something extraordinary, the third interstellar object ever confirmed by humanity. They call it 3I/Atlas. Think about that for a second. In all of human history, we've only detected 3 visitors from beyond our solar system. 3. And this one is about to do something that will force scientists to rewrite the textbooks. By August, the James Webb Space Telescope locks onto 3I/Atlas, and what it sees stops astronomers dead in their tracks. A carbon dioxide cloud stretching nearly 350,000 kilometers, almost the distance from Earth to the Moon. But that's not even the weird part. The object is accelerating. Not just moving fast, actively accelerating, faster than the sun's gravity alone can explain. And here's where it gets truly bizarre. It's turning blue. Every astronomer will tell you comets should appear yellowish or white. 3I/Atlas is becoming increasingly blue as it approaches the sun. This shouldn't be possible with normal ice and rock. Dr. Loeb from Harvard starts running the calculations, and what he discovers will blow your mind. The comet goes from shedding 330 kilograms per second to 2 million kilograms per second. That's a 6,000 times increase in mass loss. But here's the problem that keeps scientists up at night. To produce this kind of mass loss naturally, 3I/Atlas would need to be at least 14 kilometers across. But Hubble photographed it in July, and the images show a nucleus just 1 to 2 kilometers wide. Do the math. That's impossible, unless something catastrophic happened. November 10th, 2025. Loeb releases his findings publicly, and the only explanation that fits the physics is mind-blowing. 3I/Atlas has catastrophically shattered into at least 16 fragments, each piece creating its own surface area, collectively explaining the massive outgassing we're observing. It's like watching a cosmic bomb explode in slow motion across the solar system. But that's not even the most shocking part of this story. November 9th, 2025. British astronomers Michael Butner and Frank Nebling capture images that change everything. What they see isn't random debris. It's organized structure. Multiple jets extending millions of kilometers into space. Not scattered wisps, but highly directed, columnated beams of material. Some pointing toward the sun, defying everything we know about comet tails. At least 7 distinct jets showing geometric patterns and precise directional control. One astronomer described it as disturbingly organized. These aren't the chaotic fragments of a natural breakup. This is something different. Here's where conventional science hits a wall. Natural comets can fragment. We've seen it before with objects like Comet Schwarzmann-Watchman. But the jets from 3I/Atlas show geometric precision that doesn't match previous observations. The acceleration patterns don't quite fit natural outgassing models. The color change remains unexplained. The sustained mass loss rates seem to defy the physics of passive thermal processes. And Dr. Loeb asks the question that makes everyone uncomfortable. What if this isn't a natural comet at all? Now, before you click away thinking this is science fiction, stay with me, because what Loeb is actually proposing is far more nuanced and scientifically rigorous than any alien conspiracy theory. His argument isn't about little green men, it's about physics. Advanced propulsion systems, technological thrusters, can achieve far higher exhaust velocities than natural sublimation. They would require far less fuel to produce the same accelerations and jets we're observing. The organized geometry of the jets, consistent with directional thruster arrays. The anti-tail pointing toward the sun, exactly what you'd expect from controlled maneuvering. The sustained mass loss rates, achievable with far less fuel if the process is technological rather than passive. Is Loeb claiming proof of alien spacecraft? Absolutely not. He's saying the data is ambiguous. He's stating clearly that we need more observations to distinguish between natural fragmentation and something we've never encountered before. And that's what makes this real science. the willingness to consider all hypotheses that fit the data, then design observations to test them. That's not speculation. That's the scientific method in action. Here's why the next few weeks matter more than you realize. December 19th, 2025. Just weeks away, 3I/Atlas makes its closest approach to Earth. Hubble is conducting ultraviolet spectroscopy right now, analyzing the chemical composition of the gas emissions. James Webb has another observation campaign scheduled for December, using the most sensitive infrared instruments ever built. These observations will be definitive. Either they'll confirm fragmentation into multiple natural pieces, showing us a spectacular but explainable cosmic event, or they'll reveal something that forces us to expand our understanding of what's possible in the universe. This is our only chance. Once 3I/Atlas passes, it leaves our solar system forever, accelerating back into the interstellar void. The window closes in weeks, and whatever secrets this object carries will depart with it. Think about what this moment represents in human history. For the first time ever, we have the technology to intensively study an interstellar visitor during its passage through our solar system. When Oumuamua arrived in 2017, we detected it too late. It was already racing away from us by the time we realized what it was. When 2I/Borisov came in 2019, we got better data, but nothing like what we're achieving now. We have the James Webb Space Telescope, Hubble, ground-based observatories around the world, and even spacecraft orbiting Mars capturing images from a completely different perspective. 3I/Atlas is our first real-time, intensive study of an object from beyond, and it's showing us things we've never seen before. This is the convergence of advanced technology meeting an impossibly rare cosmic event. Let me put the rarity of this into perspective. The odds of detecting even one interstellar object passing through our solar system are astronomically small. Space is vast beyond comprehension. For an object from another star system to pass close enough for us to detect it, traveling at just the right angle, at just the right time in human history when we have telescopes capable of spotting it, the statistical probability is breathtaking. And we've now detected 3. Each one has shown us something different. Oumuamua was inert, showing no cometary activity, leading to speculation about its nature. Borisov was clearly a comet, behaving exactly as we'd expect. And now 3I/Atlas occupies this mysterious middle ground, definitely cometary in composition, but exhibiting behaviors that push the boundaries of our models. So here's what we're racing to answer in the next few weeks. Did 3I/Atlas fragment into 16 or more pieces, and can we observe them individually as separate objects? Do spectroscopic analyses reveal isotopic signatures that match nucleosynthesis patterns from other star systems? Can we determine what kind of stellar environment birthed this object billions of years ago? Most fundamentally, is there any evidence, any signature, any indicator that might suggest this object isn't following purely natural physical processes? These aren't rhetorical questions. They're active research objectives being pursued right now by astronomers around the world. The data is accumulating every single day. Amateur astronomers from the British Astronomical Association to observers in Australia are capturing images and sharing them with the scientific community. Professional observatories are coordinating observation campaigns. Space agencies are redirecting instruments to focus on this visitor during its final weeks in the inner solar system. Every spectrum, every image, every data point brings us closer to understanding what 3I/Atlas really is. By January 2026, 3I/Atlas will be faint and distant, receding from the Sun at tremendous velocity. By spring, it races beyond Jupiter's orbit toward the outer solar system. By next year, it's effectively gone forever, becoming too faint for even our most powerful telescopes to track. The data we collect in these final weeks becomes the permanent record of this visitor. There are no do-overs in astronomy. When the opportunity passes, it's gone. This is humanity's one and only chance to study this particular cosmic traveler. You're watching science history unfold in real time. An object born in another star system, possibly orbiting a star we can't even identify, was ejected into interstellar space through some violent event billions of years ago. It drifted through the cosmic darkness, through the vast emptiness between stars, carrying with it chemical signatures and physical properties shaped by alien stellar environments. And it arrives here now precisely when Earth hosts a technological civilization capable of detecting it, analyzing it, and asking deep questions about its nature. The convergence of those circumstances is so improbable it almost feels like destiny. Either we're witnessing a remarkable natural fragmentation event, a comet from another star system undergoing catastrophic breakup due to solar heating, creating a spectacular cosmic fireworks display that teaches us about the internal structure and composition of interstellar objects. Or we're discovering that the interstellar medium contains objects far more diverse and mysterious than we ever imagined, possibly including things that challenge our assumptions about what travels through the space between stars. Both possibilities are profound. Both expand human knowledge in significant ways. The observations continue around the clock. Astronomers in different time zones hand off tracking duties as Earth rotates. The calculations proceed with researchers running models, comparing predictions to observations, refining hypotheses. The scientific debate intensifies in academic papers, conference presentations, and late-night discussions among colleagues. And somewhere in all that data, in the spectra showing chemical compositions, in the images revealing structural details, in the trajectory calculations measuring impossible accelerations, lies the truth about what 3I/Atlas really is. What do you think is really happening out there? Is this a natural comet pushed to its physical limits by solar heating, fragmenting in ways we've seen before but never from an interstellar visitor? Or is there something about this object that doesn't fit our models, something that demands we expand our thinking about what might exist in the galaxy? Drop your theories in the comments below. And if you want to follow this story as it develops, because trust me, the next few weeks are going to be absolutely wild with new data coming in constantly, hit that subscribe button. We're living through the most significant astronomical mystery of our generation, and I'll be covering every major development as it happens. The clock is ticking, the visitor is departing, and humanity gets just one chance to learn its secrets before 3I/Atlas vanishes back into the cosmic ocean, carrying whatever mysteries it holds back into the darkness between stars. Don't miss what happens next.